Hey guys, thank you for joining us today for this great event, and I hope you will like it. My name is Luba, I'm event manager at Intelias. And while rest are joining, let's just talk about our company a bit. So interesting projects, international clients, global representation, and 8 development centers, that's what Intelias is about. For now, we create unique software solutions for more than 2 billion people with the help of 2,600 experienced specialists on board. So I invite you to check our career page, and we don't know, maybe a career match will happen. Now, just a couple of technical issues. Please write your questions to the chat, and our speaker will answer them on the way or after during the Q&A session. And also please mind that due to some issues with the YouTube streaming, we'll have like 1 minute delay with the speaker. So don't worry, she's here, it will be fine. So yeah, let's get to the event. I want to introduce our speaker for today. It's Hannah Kaplan. She's principal test engineer and lead at Intelias. I'm so glad you're here today, and the mic is yours. Good luck.
Hello, everyone. I hope you hear me quite well and everything is okay. Today, we're talking about combinatorics versus Sause-effect. Welcome, everyone, and interested in more complicated test design techniques that you might usually use in the everyday tasks. So today, we'll have a talk about combinatorics and how to choose the proper test design techniques, what are the differences, and also how to apply the tools to do the proper test design and maybe automate some of the test design tasks. It is quite an interesting approach because usually we apply test automation to actually execute tests. But automating test design when you know the proper algorithm is definitely achievable. So today we'll talk about combinatorics, purely combinatorial techniques, and cause-effect when you have some dependencies between your parameters. You are very welcome to post your questions on the chat. I will read them in mine, and I'll do my best to answer not in the real time as you have already heard, but take your time, keep calm. I will get to that, and I will provide all the answers to all the questions I will see in the chat. Also, there will be a few practice examples, practical stuff you can get your hands dirty with, and hopefully you will find them helpful. I will do my best to provide some hints and some tips and tricks on how to approach those tasks, but everyone is welcome to provide your ideas, and I will be very happy if you give some of them on the chat for me to read out, and we will get to that in the end of this meeting. Okay, so the slides about myself, not very interesting. I think that you will be able to read all this stuff later. I hope we can share the this presentation afterwards for everyone interested, or you can ping me on LinkedIn, for example, and I'll do that for you. I worked with different platforms, with different technologies, and also not only in testing, but I have decided to proceed and pursue my testing career. That was a conscious choice, and I'm very happy with that. I'm interested in algorithms, machine learning, some basics about that. And also recently, I dug a little bit deeper into AWS and the cloud technologies. And congratulate me, I got certified as cloud practitioner last Saturday. What we're talking about today. First of all, let's discuss explicit and implicit dependencies. So you read your requirements and you see some dependencies, or you do not see them there, but you expect them to be in the code, and that would be an issue. This will determine the proper choice of test design technique. Second, we will decide whether to use pairwise or something else. I hope everyone has heard about pairwise at least once, but if you hasn't, it is okay as well. We will discuss this in more detail later. If you are bored, please let me know, and I will skip this part because I don't know how good you're at it. So please let me know if it's not okay, if it's too easy for you, ping, and I will skip or be a little bit faster regarding this part of the presentation. Then we will discuss cause-effect and what is the proper approach to it, how to apply this technique and when to do it. Then we will talk about coding a little bit. You will be able to do some coding yourself if you're up to it, of course. And I will give you a few tools which will be able to do the job for you. And you will be able to then reuse the results of those tools in your end-to-end tests or system level tests, for example. So the tool will do the test design part and generate you the test data that you will be able to use in your application, in your system level or end-to-end level tests, or maybe lower level, who knows. And this data will be in some specific formats as well. You can generate it in some CSV or something like that. So something common for you to use later. Usually from practice, I apply tools for that purpose. But if you want some algorithmic practice, if you want to have a little exercise for your brain, then you can try and code the algorithms yourself. We will discuss them in detail. And finally, I hope we will get to the examples. I will show you a few, 3, and we will dig deeper into each of them. They will combine both test design techniques we are talking today. That's the idea. Okay. Let's start from explicit and implicit dependencies. What are those? So the explicit and implicit dependencies are some relations between different parameters in your requirements. What are explicit dependencies? Your requirements look like a tree. It means something like, if something happens, then something else happens. And if the previous something doesn't happen, then happens something else too. And these kinds of requirements can be shown as a tree, and that's very typical view for such kind of dependencies. Maybe you have already tested some applications, or maybe you developed if you're a developer, or I don't know what you're doing in your job, but I think that's kind of common application and part of application logic. I think that's at least once you have seen something like that. If your requirements are more or less technical, it can be a case operator. This is the case, the case operator. This is when your requirements are not only if then or if then else, but they have lots of options, and maybe options are dependent, interdependent, or have other dependencies within each. But the number of options exceeds 2. So it's not just Boolean, it's not true, false. It is more than that. For example, I think everyone has called to some support, and they usually have the voice rule there, the IVR, telling you something like press 1 to blah, 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 press 2 to blah, 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 press 3 to blah, 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 and so forth. This is an example of a case operator. So this gives you a list of choices with the single point of input. That's the idea of this kind of requirements. Then same here, your requirements might be technical, less visual. It is the same as a tree, but written in some modal language. So-called modal languages are used to express requirements in more programmatic way, and you may see something like if then, nested, if then else, and so forth. Usually the theory tells us that we can visualize such kind of requirements as a condition tree, or you can do it in a grid using something like a decision table. To me, a condition tree is more visual, frankly speaking, but if you're going to do some coding afterwards, then you might want to stick with the decision table. And if this is what you have, then cause-effect is definitely what you need. If you have explicit dependencies, what you're supposed to do is obviously to check that they are there indeed. But when you think about dependencies, it is often not enough, not sufficient to check that there are the dependencies that there should be. You also need to check that there are no other dependencies that shouldn't be there. For example, you have a few conditions, a few case conditions like press 1, press 2, press 3, and then within those rules, you are supposed to press other keys on your keyboard. But you might want to make sure that the keys which are not used actually do nothing, as they shouldn't do anything according to your requirements. Your requirements are explicit in what the application has to do, but they are definitely not explicit in what it doesn't have to do. And these dependencies which you suspect might be there during your test design, and you think about, you analyze your requirements, and you suspect that there might be some dependencies which shouldn't be there, but actually might be there in your real applications. So implicit dependencies, what are those? Your requirements do not contain conditionals. It means that there are no if-else, or if there are, the parameters there follow very strict rules and no others. Yes, so implicit dependencies, these are the dependencies which are not there. There are a lot of parameters defined simultaneously. It means that you might have the case when an object possesses lots of different characteristics, which are essentially independent by design. For example, my mobile phone has a black cover. I don't know if you see it, but here it is. And inside it is an Android mobile phone. So these two facts are completely independent, despite the fact that both of them describe my mobile phone, but from different perspectives. I can change the cover, or I cannot update the application, the operation system on my device. But I hope you get the gist of it. Yes. So these two properties describe my object, my telephone, but they are completely independent. There should be no dependencies. For example, all phones with black cover have Android. It isn't the case, and it shouldn't be the case. And this is the implicit dependency I might want to verify in my test cases. So implicit dependencies are those which might be there, but you don't want them to be there, and you are writing your test cases or checklists or whatsoever. You are creating your tests to check that they are indeed not there. The more parameters you have, the more implicit dependencies you might have in your application. But with the significant number of parameters, the complexity of your tests also increases as the number of combinations increases. You can never know which dependencies are in fact there. And for this reason, you might want to choose your tests carefully. The more parameters, the more values in them, the more combinations you can create when building your tests. But more tests means more time, and it is not always feasible to do all of them. So you might need to find some clever way to do it, some more or less efficient way to verify if there are these implicit dependencies or not. So the values that are supposed to be independent are not always independent, and you build your tests based on the educated guess that these values might be not independent. You cannot test all of it. Okay, you can, but it takes so much time that it is not feasible to do so. For this reason, we might need combinatorial techniques, pairwise, or something more complete than that. So pairwise is the case when you check each value of each parameter with each value of every other parameter. This is pairwise, so you check paired occurrences. But you can check not only pairs, you can check triplets, quadruplets, quintuplets, and so forth. So pairs might be good enough for you, maybe not, maybe yes. This is what we need to think about when coming up with test cases based on implicit dependencies. It is up to you to think about how many values can cause an error, but be careful. The more values you combine, the more tests you get. And unfortunately, the dependency between the number of tests and the number of values you combine is geometric. So it goes very fast up when you add a new value in the combination. For this reason, combinatorial coverage when you test for explicit dependencies is something you need to think very carefully about. Any questions so far? Okay, I know that we have the delay here, so we will. I will come back to the slides if you want me to. I will come back to the slides I have already covered. Just let me know. Pairwise or not pairwise? What should we do? And why actually pairwise? The idea behind pairwise is quite simple on the one hand. On the other hand, it is clever enough for us to be satisfied with this technique in most cases. So we don't often need something more than pairwise, though I can come up with some examples where we might need something more than that, but I won't spoil the, the rest of the slides right now. So I hope as soon as we get to the examples, you might be able to come up with some yourself or afterwards. So why pairwise? First of all, pairwise tests do not increase in number significantly when we add new parameters or new values to already existing parameters. We will discuss it a little bit later on another slide why it is so, but if you cover all the combinations of your values within your parameters, you see that the number of tests grows exponentially. So pairwise is essentially quite wise, sorry for stupid pun, way to save the number of tests while keeping your coverage on more or less acceptable level. So the first chart to the left shows us the number of tests with the number of parameters. So factors here are the number of parameters you add to the model, and these show the number of tests that you create when you cover pairs, pairwise case, yeah, the solid line, and the dotted line shows you the number of tests and how fast they grow for full combinatorial coverage. So pairwise is every value of every parameter means meets with every other value of every other parameter. And for exhaustive case, it means that all values need to be needs to meet together with all other values. So these are all possible combinations. Here we go, the explanation why pairwise, why not triplets, quadruplets, and so forth. It is, I suppose, quite obvious that in most cases, the error, the kind of problem you find lies within one parameter. So there is only one thing in your application causing the problem. Why is that? It is because the complexity of the source code increases if two or more values are somehow intertwined to produce an error. Example, you have a form where you choose gender and age, two parameters. You might notice that you are not allowed to put age under 18 for any gender. Just you're not allowed to put age under 18 in the form, though you should be able to. This is much easier from the source code perspective than an error like you cannot put the number under 18 for females only. So I hope that some of you at least can imagine the code supporting the sentence females only cannot be under 18 and anyone cannot be under 18. The case with females obviously has two conditions involving two parameters instead of the single one as in the previous case. People under 18 are not allowed, no matter the gender. In the second case, when we have both gender and age, there is just more code. So in order to make such kinds of an error, you need to write more code, more erroneous code than in the first. This extra condition just makes things harder. And when you write code, it is more difficult to make such kind of a mistake. For this reason, most of the errors are occur just because of one single thing, and that's it. It doesn't mean that there are no other errors occurring because of some complicated conditions in the code, causing essentially these pairwise, the errors you occur that occur because of pairwise and or maybe triplets or quadruplets and so forth. But the number of such errors goes down with the number of parameters included in the condition, because the code just gets harder and harder and harder when you add more and more conditions. And for this reason, the more conditions you include, the harder the code gets, but the fewer errors of this kind you find. So here you see that the number of tests goes exponentially, but the number of errors you might find also decreases, and also exponentially. Pairwise is therefore some kind of a compromise here. You see that the number of pairwise tests doesn't go exponentially, but there is still a feasible amount of errors you might hunt for if you apply pairwise. So pairwise is the compromise, the balance when it is still worth it, when it is still okay and feasible to use combinatorics, while more than that increases the number of tests sooner and provides fewer errors than that. Is it applied to explicit data sets only? Yes. Unfortunately, you cannot do it with non-explicit data sets. When you come to application of combinatorial techniques, you have already done your homework. So in order to apply this stuff, you first need to do your equivalence partitioning, your boundary value analysis, and so forth. So in order to apply any combinatorial techniques, whatever they are, you first need to do the simple stuff. So you need to choose the values on which you're going to test. It means that you can apply pairwise to whatever real numbers you have, to any ranges you have, but you still need to select the explicit numbers or the explicit values of your parameters, which you are going to combine. Okay, hope it makes sense. So pairwise means that we are going to combine every value of every parameter with every other value of every other parameter. Only pairs. But note that the more parameters you have, the more pairs you have in each test. So each test consists of these tuples of values. So each test includes more than one pair, and each test covers as many pairs. Okay, I won't say you. I won't tell you how many pairs covers the test, just not to spoil the rest. But keep in mind that one test covers definitely more than one pair, and that is how we can get this thingy. You can see that the number of tests doesn't grow exponentially. Pairwise allows us to cover many pairs in one test. And that is what we're doing, thanks to which we get the opportunity to reduce the number of tests. Okay. That's it. And if you're considering more than pairs, keep in mind that adding one more parameter to your pair in case of pairwise and making it triple-wise or quadruple-wise will increase your tests more than this nice slowly growing line. And you'll get this, which is the so-called combinatorial explosion. Now triples and quadruples. So here you go. The answer is here. The classic bell curve. Yeah, the so-called bell curve. Okay, here's the nice picture that explains pairwise in a little bit more detail. Okay, we have three parameters, each of which can be either 0 or 1. Okay, so we have three Boolean parameters. If you think in design form, then imagine that you have three yes/no questions. For example, radio groups with 2 options each, something like that. We need to build the tests that contain all pairs of the values between every parameter. So we need to make sure that 0 and 1 from the first parameter meet at least once with each 0 and 1 of the second parameter. Then we need to make sure that the same 0 and 1 of the first parameter meet at least once with 0 and 1 of the third parameter. And you get the idea. Every 0 and 1 of the second parameter need to meet at least once every 0 and 1 of the third parameter. So here is the picture which shows this idea. We have parameters 1 and 2, and here are all possible pairs, all possible combinations of their 0s and 1s. Here in the red circle, yeah, red oval. 0 from the first parameter meets 0 from the second. 0 from the first meets 1 from the second. 1 from the first meets 0 from the second. 1 from the first meets 0 from the second. Sorry, meets 1 from the second. And the same works for all other pairs. For all other pairs of parameters. But note that we have 3 parameters, and therefore the test essentially consists of 3 values, not 2. As you can see from the picture, every test covers 3 pairs: first and second parameter, first and third, and second and third. You see that they are color-coded here. So in each test with 3 parameters, we have 3 pairs out of these all possible combinations here, out of these tuples. The green ones are the tuples which can be found in the second test. The blue ones show the tuples which are in the third test, and the brown ones show the tuples which are in the fourth test. You can see that the number of pairwise tests here is 4. And there are 2 questions from my side. I suppose I will give you a few minutes or something to make sure that I can get some answers. First question is the following. Is it possible to build other tests, so the combinations of these zeros and ones here, so that they contain the same pairs, yeah, the same tuples, but the combinations are different, not increasing the number of tests. So we need to leave them as is. We need still 4 tests, but can we have other combinations here, not 0, 0, 0, 0, 1, 1, 1, 0, 1, 1, 1, 0, so that the property of containing all the tuples was still there. Is it possible? Is it not possible? Can we do it by combining these tuples from these 3 parts in another way? Or is it not possible? This is the only possible way to cover all the pairs among these blocks of parameters, yeah, 1, 2, 1, 3, 2, 3, and is it the only way, so that the property to contain all pairs was still there? Is it possible or not? I'll give you, I don't know, 30 seconds, maybe. I hope that the delay is not that long. And I hope that someone is still there listening. So let's participate a little bit in the discussion. No answers for now. Okay. Okay, I'll give you a little bit more time, and then I'll give you the answer. Is it possible to build the tests otherwise, so that they still contained all the pairs? Okay, I'll give you the answer then. So yes, it is. Yes, it is possible. Thanks, thanks for participation, guys. Yes, it is definitely possible. When we build such kind of tests, we combine 2 pairs by choice, and the third one occurs kind of automatically. Let's see how it works. For example, let's take this first red one. I choose to have 1, 2 as 0, 0. It means that the second pair, second and third parameter, can start from 0 only. That's the restriction, as I have selected this tuple as part of my first test. So I have 0, 0. I've fixed 0 in the first parameter and 0 in the second parameter, but I can still vary the third parameter. Here you see that we have chosen 0, 0 as the third, but there is also this one, 0, 1. And instead of 0, 0, 0, we could have selected 0, 0, 1, thus covering another set of pairs. We have this one. Now we have this one. And instead of 0, 0 here, we automatically obtain 0, 1 for the third pair. And in this way, you can change the number of, sorry, not the number, but the combinations of tuples in each test, but still preserve the property of having all the pairs within the 4 tests. And why 4? Why 4? Can we do better? What do you think? Can we build fewer number of tests still containing all the pairs? Can we do better than 4? Is it possible or not? And the second question is, what if we want all combinations, all possible combinations of all parameters, not only pairs, but in our case, triplets. So I want all possible combinations of these zeros and ones in every parameter. First question, can we do better than 4 for pairwise? Second question is, how many tests are there for all possible combinations, full combinatorial coverage? So I'm trying to show you how much we win with pairwise, how it gets better if we use pairwise. I'll also give you a little bit of time for that. Can we do better than 4 for pairwise? And is it possible to have all combinations? Okay, how many tests give us all combinations? Yes, indeed, Valentina, thanks. We cannot do better than 4, and the answer to this second question is indeed 8. So in order to build all possible combinations, we need 8 tests, and we cannot do better than 4 tests in pairwise. Now, a little bit, we get things a little bit more complicated. Yes, thanks, guys. You're quite right. Let's complicate it a little bit. Let's add the third value to our first parameter. So now it has not 0, 1, it is no longer Boolean, okay? Now it is 0, 1, and 2. Same questions, okay, more or less same. How many tests we get if we use pairwise? How many tests we get if we use all combinations? Is it better? Is it worth? How much we earn if we apply pairwise in comparison with all possible combinations? So we have 3 values in first parameter, 2 values in second parameter, and 2 values in third parameter. I am not adding a new parameter here. I'm increasing the number of values in one of the parameters. Hope it makes sense. All of this stuff we are discussing. Three, two, two. The number of values in each of the parameters. And the questions are, how many tests we get if we use pairwise? And the second question is, how many tests we get if we use all combinations? 27, or that's a little bit too much. There are fewer than that, 12, indeed, 12 for all combinations. So essentially, in order to get the number of tests for all combinations, Valentina is quite right, you need to multiply all the values in all parameters. In our case, it's 3, 2, 2, and therefore, if you build all possible combinations, you multiply these values. So instead of 2, 2, 2, and 8, as in our previous case, 2 times 2 times 2 gives us 8. Now you have 3 times 2 times 2, and this gives us 12. Indeed. What about pairwise? What's our best chance? How many tests we save in comparison these 12 if we apply pairwise? You can see how they are built here, from this picture. So we cannot do better than the hugest number of pairs between two parameters. What's the hugest number of pairs between the two parameters? We cannot do better than that if we build pairwise tests. And this is, yes, 6, exactly. Thanks, Valentina. 6 is 3 times 2. So in order to get the number of pairwise tests, what we do? We order our parameters by the number of values in them, from top to bottom. So you sort them, you order them from the hugest number of parameters to the lowest number of parameters. And you multiply the first two. So the hugest and the second one. And this gives you the number of pairwise tests. You can see here that you remember this smooth curve from the previous slide. If you increase the number of parameters, but the number of values in them don't fall into the first two, you still get the same number of pairwise tests. So your number of tests doesn't increase in pairwise when you add new parameters if the number of values in them is fewer than the number of values in the first two hugest. Okay? Hope this is more or less clear. Let's sum it up. In order to calculate the number of pairwise tests, you order your parameters according to the number of values in each, from top to bottom. So hugest first, smallest last. Then you multiply the number of parameters in the first two, the hugest and the second one. This gives you the number of pairwise tests. In order to calculate how much you win, you need to multiply all the values, all the numbers of parameters for all the parameters in your line. This will give you the full combinatorial coverage. Subtracting the two values will give you the win. So this is the number of tests you save in comparison between pairwise and full combinatorial coverage. I suppose it is clear how to calculate the triplets, the quadruplets, and so forth. So instead of multiplying the first two, you take the first 3, the first 4, the first whatsoever. And you can see that the more you include in this multiplication, obviously, this fast, the number of tests increases. But remember about the payoff, so the bell curve. The more parameters you include, the fewer you win. You make more tests, but you find fewer errors. Okay, that was it for pairwise as a technique, yeah, as an explanation. If you have any questions on that, please drop them in the chat. I will answer. How to choose? Yeah, pairwise or not pairwise? First of all, remember that these are independent parameters. You are looking for implicit dependencies. If you're applying pairwise, you are doing something like there is a huge field and you expect that there are some pests there, and you are throwing some kind of insecticide on those fields, hoping that your pesticides will kill those insects. That's how it works. But you do it more or less wisely, covering the huge portion of the field where the pests are the most likely to be. That's the idea of pairwise. So you have independent parameters, but they are seemingly independent. You think that there are some implicit dependencies there. There are no logical connection, no dependencies, nothing. They are independent and they should be that way. The number of values is significant, and you don't want to do the full coverage. That's the point. And the number of bugs that you have maybe accidentally discovered when doing some exploratory testing on some combinations of parameters is more than 0. You have some bugs that you have discovered that you believe are caused by implicit dependencies. Not pairwise. You have the independent parameters, but they are logically grouped. You will see an example in our examples section of this meeting. So I'll show you the example of these grouped parameters, which are still independent. The example here is coordinate of points in three-dimensional space. If you're not limited in this space, so you can set any triplets of coordinates. This is not some kind of a sphere or maybe a cube or something. So you have no limitations on the parameters. They're independent. You can choose any point in space, but each point in space is described by 3 numbers, not 2, not 1, by 3 numbers. Though they are independent, they are logically grouped. These are 3 parameters which logically describe one object. And you work on the objects level. So you are interested in the point, not in one of the coordinates. In this case, you might not want pairwise. You might want triple-wise. Or you might want triple-wise in some clever way, or pairwise with triplets you have built separately. There are several approaches to that. If your data are not independent, please note that this is cause-effect. If you have dependencies, you need to check them first. They are in your requirements. Go happy path. Take this happy path, test it first, cover these dependencies by your cause-effect based tests, and only then come back to possible implicit dependencies which might or might not be there. Okay. Any questions so far? If we have 4 parameters, each of them has 2 values, we'll have 4 pairs as an output. Indeed, even if you have 5 parameters and each of them has 2 values, you have still 4 pairs as an output. 4 tests as an output. Okay. So the number of pairs in those tests, let me come back here. The number of pairs is 2 times 2, 3 times, yeah, 12. But if you are talking about the number of tests as the combination of all 3, this is 4. Even if we include fourth parameter and it is still 0, 1, the number of tests in pairwise will still the same. Will stay the same, but we will add quite a few tuples if we add fourth parameter. So we will need to cover first and fourth, second and fourth, third and fourth, if we add fourth one. Okay. Hope it makes sense. But fortunately, the number of tests in pairwise still stays the same if we add fourth parameter with still 2 values. Okay, cause effect. I suppose it is quite conventional way of doing this kind of testing, and you might be used to it. Here, this is the decision tree. Here is the table, decision table. You base on this decision tree. You have parameters here, outlook, windy, and humidity. Outlook takes 3 values, windy takes 2, humidity takes 2. You have the target, which can be yes or no, and you can see how this goes through the decision tree. Note that if outlook is equal to overcast, we essentially don't care about windy or humidity. This is the example of implicit dependency. So there might be a dependency, but according to the requirements, it shall not be there. You see that for sunny, we use only windy as the second parameter, and for rainy outlook, we use only humidity as the second parameter. So if the outlook is rainy and humidity is high or normal, windy has no influence at all on our decision. If outlook is rainy, we ignore windy. If outlook is sunny, we ignore humidity. We should ignore, yeah? And if the outlook is overcast, we ignore both windy and humidity. These are the so-called implicit dependencies I have talked about before. The explicit dependencies can be visible here. So the values of these 3 parameters define the outcome. And if the outlook is overcast, we don't care about the values of windy and humidity. And we decide here is also temperature for some reason. Don't know. Maybe there was some other parts of the tree which we don't see here, but you see humidity and windiness here, and they have no influence on the result. The outlook is still yes. Whatever the values here, the outlook should be yes. We might be sure about that, or we might not be sure about that. You get the gist of it. So we can still be willing to test all possible combinations of outlook equal to overcast with all possible values of windy and humidity, just to make sure that these 2 parameters indeed do not influence the result. All possible combinations in the decision tree give you the so-called full decision table. So if you combine all parameters, you create all the combinations, and then you check the results according to the decision tree. This is the full decision table. But if you follow just the outcomes on the decision tree, so essentially you test once overcast with some parameters and delete the rest of the tests, as you're 100% sure they don't influence your result, then in this case, you can build the so-called contracted decision table. It gives you full coverage of your outcomes, but it doesn't give you full, you're not 100% sure that it'll always be yes if the outlook is overcast, as if you delete all the tests except for one, you don't test either for other parameters, for other parameter values, or for all their combinations, of course. That's the idea. So that is how the two techniques are interconnected. And the idea is, of course, first and foremost, to test how you go through decision tree. So all the leaves, no's and yeses in our example. And second, you think about building the combinatorial coverage on what is not there. That is how you approach those kinds of requirements. You might notice that this is quite a simple one. The ones you work with might be more complicated than that. But still, note, cause-effect gives us all possible hypotheses, everything that ends with the leaf, with the decision, yeah, these ones. And combinatorial techniques, pairwise, triple-wise, quadruple-wise, and so forth, give you the negative tests. Okay, hope it makes sense. Please ask your questions, if any. Let's move on coding it. I think we will share the presentation, or ping me, I'll do that. There are a few links you can read on the logic, how to implement pairwise. We have discussed in detail how the tests are built, but that was the very simple case, the simplest one. In reality, you see that it is more complicated than that, especially if there are those additional conditions that you have seen on the previous slide. If you want to build pairwise tests based on some interdependent parameters, you might be willing to add some constraints to that. Like, I do not want these two values to ever meet, for example, or if this parameter is equal to 1, then this and that parameter cannot be equal to 2 and 3. Yeah, these kinds of dependencies are possible, as you have seen on the previous slide. And when you're building the negative tests based on combinatorial techniques, you might be willing to keep that in mind somehow. It is much more complicated task than just combining the tuples, as we have done before. And for this reason, you can check the math if you are willing to. You can check the tools which implement pairwise, so which give you the tests if you provide the tool with the set of parameters and the values you have chosen for them, or which were available for you, like in the previous example with windy and overcast and so forth. So you have the tool, you give it parameters and their values, and the tool gives you the tests. Almost all such tools can support some kind of settings. So you can add the constraints, you can select the number of parameters you want to combine. So it might be, instead of pairwise, you can build triple-wise, quadruple-wise, and so forth. You can choose the constraints and provide the dependencies between parameters. You can mark some of the values as negative so that you were able to distinguish between positive and negative tests, and so on and so forth. The tools are quite powerful. You can find the list here. I suppose the most popular one is PICT. This is the Microsoft one, which is open source. And I suppose there are lots of tutorials. Actually, it is very simple. It is CLI based, and there is one page of help, and it is very easy to use. It takes a file with your parameters and values as an input, and it can provide the output in the commands line, in the file, in text file, and CSV, whatever you want. Of course, There are also different implementations. I have provided Java and Python. Sorry, guys. Sorry, everyone who writes and uses another programming language. This is so popular that you can Google and find your implementation. It is definitely available for all popular programming languages. So Google pairwise plus your programming language, you are very likely to find something. And as for cause-effect, the task is also more or less algorithmically covered. Cause-effect is a tree. And what you essentially do is covering all the paths through that tree, reaching the end leaf. And that's it. So, of course, there are algorithms covering this task. You can also find the implementation here. If you want to get more generic than that and, for example, build more extensive coverage based on the tree, if you have something very complicated, you might want to check all the paths through your tree, not only check the end leaves, yeah, but also check all the possible paths through your tree. Then you might want to use some graph-based libraries and consider your tree as a graph and apply the corresponding algorithms. So the graph algorithms to cover all possible paths through a tree. That is not very complicated stuff, as we are using the already existing library, and if you're okay with the standard data structures, you should be fine with any of them. Okay, that's the answer on how to code it, and now let's go to the examples. Looks like we're good to go, at least. Yeah. Any questions so far? And I have created a QR code for Picked Online if you want to do the examples and try the tool for pairwise on your own. As you cannot click the link, you can use the QR code and open the tool, or just Google it. It is very easy to find. Or you can use any other implementation or any other tool of your choice. We will do some examples now. Any questions so far? So I will leave this screen and I'll give you a few minutes before we proceed. I see that there are no further questions, but okay. A few seconds more and let's go to the examples. Okay, so no questions so far. Please ask if any. And so let's consider our first example. This is actually the one very close to what I have mentioned about the points, but in a little bit more complicated way. We now have three parameters, each of which is described by three XYZ parameters. There is no dependency between X, Y's, and Z's. There is no dependency between these parameters. So this X doesn't influence anyhow on this X, doesn't influence anyhow on this X. You get the gist of it. At least it shouldn't. So we are not sure if it influences or not, but at least it shouldn't influence. Let's imagine that these parameters change from 0 to 1 or with the step of 0.1. So these are decimals. Yeah, we have 1 decimal. And the step here is 0.1. The range is from 0 to 1. So each of the parameters here can change from 0 to 1 with the step of 0.1. As you can see, we have 9 parameters here, and you see that each of them can essentially take 11 values, yeah, from 0 to 1, 0, 0 0.1, 0 0.2, and so forth, 1.0. And they are 9. So if we consider all the combinations, yeah, the whole number of them, that'll be 11 times 11 times 11 times 11, 9 times, which is quite a significant number. However, we might think about reducing the number of tests, but we need to be careful here. Should we use pairwise? Should we use something else? Should we do some preliminary combinatorics here? For example, we can use as parameters not a single number, but a combination of them. So we can come up with some values here, some values here, some values here, and then combine offset with tiling, offset with angle, tiling with angle, if we decide on pairwise, of course. And the values will be the sets of 3. So the values of these parameters. Or we can choose to combine the triplets, XYZ, 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 and we can build our combinatorics based on the triplets, like every triple. And in this case, the number of tests will be respectively 11 times 11 times 11, which is still quite a lot. But considering these as parameters, yeah, this offset, tiling, and angle, and using the combinations of values here is maybe a more efficient way to do the job, and we can reduce the number of tests, still being more or less sure in the result, as if we do that, we will exclude the combination of all possible triplets of x's, xyz's, xyys. So xxx, xxy, xxz, these are unlikely influences. And for this reason, we might not be willing to combine just all triplets, considering all the 9 parameters as separate ones, as 11 times 11 times 11 is still quite a lot. Even if we choose instead of all values 0, 0, 1, 0 0.1, 0 0.2, and so forth, only 3 values, it is still okay, maybe not 3, 5 values, yeah, 0, 0 0.1, 0 0.5, 0 0.9, and 1, yeah, for each. It is still 5 times 5 times 5, which gives us 125. Which is better than 11 times 11 times 11, but still maybe quite a lot for you. We can reduce the number of values and therefore reduce the number of tests, but you might not be satisfied with the coverage. We need to test all the values given you by boundary value analysis. Therefore, in this exact case, I would suggest to consider offset, tiling, and angle as parameters, and as values, give the sets of these XYZs for each. For example, we can consider offset, and here we want to test 0, 0 0.1, 0 0.5, 0 0.9, and 1. Same here, same here. We are not willing to do all possible combinations here. We are not even willing to do all possible pairs or something. We just want that every value in every parameter is in at least one combination. In this case, we will be done with 5. So we have 0 0.0, 0 0.1, 0 0.5, 0 0.9, and 1. And same here. And if we choose 0, 0, 0, 0.1, 0.1, 0.1, 0.5, 0.5, 0.5, you get it. We will get 5 tests covering all values. Maybe we should do something more complicated than that, but you can mix up the values, yeah, and this will still leave 5 tests for this triplet. And in this way, we can consider each parameter and save each 5 tests for each of them, yeah. And then we can use pairwise or maybe all possible combinations if you're willing to, but that will give us more control than just combining all possible values. And if we have 5 here, 5 here, 5 here, pairwise gives us 25 and full coverage gives us 125, but it is cleverer and better than 0.0, 0.5, 0.1. So when we do the same in this uncontrolled way, when we want all parameters, all pairs of parameters within the 9. I hope it makes some sense to you. Any questions, any suggestions how to improve it? Any ideas on test design for this example? Let's give you some time, about 30 seconds or minutes. Guys, any questions so far? Okay, I hope that was clear enough. And you can apply the same idea to your sets of parameters, which are to be independent, but might not be so independent as you want them to. Let's go to the second example. This is an interesting one. I hope you have seen the control a lot of times. And this is the output. So below, you see the output. This is the read-only part. It is not something where you can choose the date. This is just read-only. Okay, this just shows you the results. And the parameters are on top of this form. You have the date, you have the month, you have the year as the last 2 digits in a year. You have time. This goes from 0 to 12. This goes from 0 to 59 and AM, PM. Hope that is clear. Time is not shown here, so time doesn't influence the output. It might or might not influence the output. We hope so it doesn't. So according to our requirements, time is used somewhere else in the application. Not important for our example. Time is used somewhere else. It shouldn't influence our input here. What influences our input here are these 3 parameters. You might see here 2 parts. The cause-effect part. So these parameters are obviously interconnected. This ranges from 1 to 31 and depends on this. And this might also depend on the exact value here and here. And these 3 definitely influence our output. And these 3, yeah, 1, 2, and this true-false parameter, yeah, AM, PM. This shouldn't influence our output, but might, yeah, might or might not. We don't know, but we might want to test that. So we need to select some values to input here. And we need to select some values to input here. You can see that there are 6 parameters on this form, okay? each of which has quite a significant number of values, and we are definitely not going to test all of them. However, we might want to test all of them for some of the parameters, but not all. For example, month contains 12 different values. We are definitely going to help at least 12 tests. So we are able, by changing the month in every test, to cover all possible values of months by our tests. However, it is highly unlikely that we cover all possible values of hours and minutes. Maybe we are willing to, but 60 tests is a little bit more than you might be willing to do if you're doing that manually, of course. But if you're doing some automation, it is okay. Let me give you an example of applying cause-effect for negative tests. There are some explicit dependencies here. We know that the number of days in a month depends on the month. There is strictly defined dependency. We see every day in a calendar. If you do some planning, you see the calendar every day, and you definitely know how many days there are in every month. Some of the months have fewer days than 31. Therefore, you can build the combinations of valid values in all fields, while the whole value, so the whole object defined by those values, will be invalid. Okay, so we have three parameters defining one object. The object now is a date. Okay, there is a date, and a date consists of a day, a month, and a year. Valid values for day in the date are 1 to 31. Valid values for month in a date are from January to December. Valid values for year might differ, but let's consider it 1970 to 2022. Okay, so a lot of years for us to cover. That's 12 months and 31 days. As we know that the year consists of strictly defined months, not all of which contain exactly 31 days. Knowing this, we can build negative tests from correct values, but leading to the incorrect days. For example, we definitely never have 30th of February in any year, despite the fact that February is allowed. Any year between 1970 and 2022 is allowed. 30th February is definitely not allowed, despite the fact that 30th of May, for example, is quite okay for us. We can build such negative tests from the knowledge of interdependencies between the months and the days. Okay, that is how cause-effect, these explicit dependencies, give us the opportunity to build not only positive tests, but also negative tests. These negative tests, within this example and within every other case you meet in your practice, will provide the following. You build incorrect, invalid objects out of valid properties. So every object is defined by some properties, and you combine them in some way which is not allowed. So you take valid values of parameters, combine them so that you get an invalid object. That's what cause-effect also gives you. Of course, you can combine them using pairwise, some of combinatorial techniques, but really it is not worth it. So you will get a lot of tests, and if you want to build only these negative ones, it is much better to use cause-effect, your knowledge of these objects and their dependencies between their properties, instead of combining all possible value with all possible other value, so that some of these were incorrect. Okay, hope it makes sense. I will proceed, but I want you to think on the following question. How many invalid dates are there in a year built out of valid parameters of a date? So the examples here are 30th of February, 31st of February, and so forth. So you have valid parameters for date, month, and year, but the whole date is invalid. How many such dates are there in a year, and does it depend on the year or not? Okay, these are the questions for you to think about. Once again, how many invalid dates built out of valid parameters, day, month, and year, are there in a single year, and does this value change from one year to the other? Okay, that is the question. In the meantime, let's consider some tests here. First of all, we might want to see if our date is correctly shown within the range. So we might want to see if the 1st of January of 1970 is shown correctly, and the 31st of December of 2022 is shown correctly. You can apply the standard test design techniques like equivalence, partitioning, and boundary value analysis here. And you can also check if the time somehow influences the way how the date is displayed on the calendar. I would also like to ask you which times you'll choose for this check. Influence, and if the time influences how the date is displayed. But okay, let's wait for the answers for the previous questions, and then we will consider this one. The time doesn't influence this part of functionality at all, and actually, if we considered only cause-effect without any combinatorial techniques, without pairwise and the stuff, we could just do our date test and be satisfied with it. This is the example with decision tree, where we have additional parameters, but they don't influence the result in some cases. Here, if we use cause-effect, we can just input any parameters here and be satisfied. That will be enough for us. However, we might want to choose a few values here to test some boundaries, and we might want to check some combinations between maybe days and is worth it. Maybe here between the year and minutes, if they coincide or something. So here you see that there are a lot of values. You can build some kind of combinatorial coverage, but frankly speaking, I cannot come up with any implicit dependencies I would like to test here. However, it doesn't mean that we should exclude the time at all. Just leave it as is. It is not so. You might want to come with some kind of points you want to test. Like, what happens if year and hours are the same? What happens if year and minutes are the same? It is not worth checking all the pairs between the two. But if you can come up with some values you want to test, that is the way to proceed. It is not worth checking full combinatorial combinations, full combinatorial coverage. It is not worth building pairwise here, but as you still have the time, you can just add it to your tests based on the date in some very clever way. And that's it, be done with it. Valentina, thanks a lot. You're fully right. It does depend on the year, as some years are leap years, and the ordinary years, not leap ones, have respectively 7 invalid combinations. Thanks a lot. Of course, yes, Anna, also thanks indeed. Leap years have fewer invalid combinations, and therefore one less, one fewer than non-leap years, and that will give us 6 invalid combinations for a leap year, because 29th of February is the valid one. But same here, we can still apply combinatorics for these parameters and add some values for these in some clever way, as I have proposed. Here, you might still want to build not only negative tests, as we have discussed, but obviously some possible positive ones too. And that is where you can apply your pairwise if you can come up with some values you want to test. This is the way to go here. And the last question is, can you propose sometimes so the values for these 3 parameters, hours, minutes, and AM, PM, you want to test with the date. So the date, and how can we define the time so that it could, maybe it won't, we hope it won't, but what are the values you want to test which might influence this output? So which values of time you might want to test as an error guess? Which values of time might influence the output for the date? Maybe there are some other implicit parameters not present here you might want to consider for such tests. There might be others. So this is the UI, obviously, and there might be parameters somewhere under the hood, behind the scenes, that influence the output here out of this UI, but still there somewhere. Times in the future. Okay, nice. So if we have the constraints about date and time in the future, we will want to test the current date with the time in the future. Nice. What else? Oh, nice. The verge, the brink of the year, and the values, thanks, Katya. The values on the brink of the year, maybe on the brink of the month, but still, time 0, 0, 0, 0. And we might want to see that the date is shown as here without the influence of moving it to yesterday or to the day after, to tomorrow. Thanks. Same here, you might want to test 2359. You get it, I hope. Thanks a lot, guys. What is also, just as an idea here, you might want to test time zones if it is important for your backend. So these might be the clients and they might be in different time zones. And you might see that the time conversion happens properly. Also, one point to verify is the point where you change the clock. So when you put it 1 hour back or 1 hour forth. Okay, for the countries where it is possible, it is available. This is also one thing to consider, but this is the backend. This stuff is the front end part, and there might be something behind the scenes for us to pay attention to. And finally, the last example, I want you to maybe have a little think on it. I want you to leave it and to leave it for you to consider. And all the dates larger than 31, yes, we definitely need the negative test there. Remember that first, before doing any combinatorics, any cause effect, anything, you need to test each of the parameters separately. Is it infinite number of wrong dates? Of course it is, but note that you first test the negative, the negative inputs, 32, 0, negative, real, special characters, letters, and so forth. And if you're lucky, they are not allowed, okay? If they are allowed, do not do any combinatorics or cause effects or whatsoever. Fix this stuff first, okay? If you see that negative values are allowed, you will indeed have the infinite number of wrong dates. That's not the way to proceed in it. You will be sick and tired of testing by the time you finish with this little form, likely little small part of your application. So before proceeding to any combinatorial techniques, to any cause effects, to anything which combines your parameters one with the other, test each of them separately. Apply your equivalence partitioning, apply your boundary value analysis, check that each of them works. And as soon as they work, each separately, proceed with combining them. As you can see from this form, it is essentially impossible to make them independent, like test one of them in single box without influencing, without the other influencing this one. But this means that you have to build your negative test with these invalid parameters, invalid values like letters, special characters, real numbers, and so forth, one at a time. Okay, so this means the following. We want to test 32 here. We put 32 and we put valid values here. 32 is allowed. We are disappointed. We file a bug report. We don't do any combinatorics until it's fixed. Then we try to select or to add somehow an non-existent month. It is added. We are disappointed. We file a bug report and so forth. But when testing each of the negative cases here, the invalid ones, completely invalid, I mean that which are not allowed, you fix the other values on positive, on some correct values to make sure that separately each parameter works as expected. This will allow you to get rid of this infiniteness, of this infinity when you combine the wrong values. Usually it makes no sense. The reason is that you shouldn't be allowed this input anyways, and there is no need to combine the non-allowed input here with non-allowed input here. If you are able to provide non-allowed input here, and you're willing to find out what happens if these two are combined, you have problems worse than combining negative inputs. You're just allowed negative inputs. That's your problem. So stop there, fix this one, and proceed afterwards. Okay, hope it makes sense. Hope so. Okay, the last example, and I will leave it to you to build some tests here, but I will give you some ideas. We see here first name, last name, which are strings. We see here credit card type. We see here credit card number, month, year, CVV2 code. Okay, some of these parameters are dependent. I won't give you the explicit dependencies, but you can Google it if you're going to give it a try. The card number is dependent on the card type. So here are the card types, and the card type influences the card number. The allowed characters, the exact numbers used in the card number. So there is the dependency between this one and this one. Moreover, is this actually a number? If you consider the data type here, is it a string or is it a number? That's the question. So I won't give you an answer right now. Let's give it a try. Credit card number, is it a number? I mean, an integer, or is it a string? There's very important distinction here, because you will see lots of values like this in different cases, in different forms. An integer or a string, how do you think your developers store it in their databases? A string, indeed, but note that it is a string consisting of numbers, of digits. Yeah, yes, it is a string. How to distinguish between the two? If you have a string consisting of digits, leading zeros should not be cut. That's very, yes, but as for CVV, you might be in trouble. Okay, I won't give you my CVV, but I'll explain why. So if you store it as a string, leading zeros won't be cut as they shouldn't be. Yeah, you may have the credit card number starting from zeros in theory, and these are meaningful zeros. You'd better not lose them. So your credit card number usually consists of 4/4. Yes, so four digits, then 4 digits, 4 digits, and 4 digits. 16 digits in groups by 4. First digits in the first group might be zeros. There is a possibility. And if you store your credit card number as an integer, you will lose them. Yeah, they will be cut. And that's kind of disappointing. You shouldn't do that. So if you have a string consisting of digits, it should stay a string. You can do some conversion here and there, but you should be very careful with that, because comparing the strings, e.g. your user inputs here and you compare to the value in the database, and if your front end considers this a string and your database considers this an integer, you're in trouble. Actually, your user in trouble, but I suppose you are as well. Same goes for CVV. Yeah, you can have letters as a card number. Maybe, then it is definitely a string in it. CVV is 3 digits, and same here, it is a string consisting of digits. And leading zeros is the typical problem and the easiest way to check if it is a string or if it is an integer. This goes for zip codes and lots of other cases. I think you can come up with more yourself. You get the gist of it. So for strings consisting of digits, leading zeros are the test which gives you the answer if this value is stored properly. Actually, you don't care how it is stored, yeah? You just care about the business logic, if it works or not, if your users can get the results they need or not. So check the leading zeros and you'll see. Second point to consider, you have month and year here. Month and year cannot be in the past. Yeah, I don't know if there are any restrictions in such cases, like them not equal to the current month and year, but it shouldn't be the case. Month and year shouldn't be in the past. That's the common constraint here, yeah, for month and year. And finally, first name and last name. You can consider this as strings, and you can come up with values for first name and last name to do your combinatorics, but you can get deeper than that. I wouldn't suggest you doing this here with this example with first name and last name, but you might want to do it for your passwords. Password is a string which requires following some rules. Yeah, like containing upper and lowercase basic Latin character, a digit, a special character, not containing some characters, and so forth. Yeah, the length, minimum, maximum. So there are some rules to this string. The rules to such strings are usually not so strict, but the stricter the rules, the more you might want to consider the string as a set of parameters. What will be the parameters here? You can consider each character in a string sorry, as a separate parameter. Shouldn't be the proper way to do with first name and last name, but you might think about it if you test a password on the registration forms. So there are different ways to choose every character in a string. And the string also has length as parameter. If you build your combinatorial model based on this approach, the number of characters in a string and each character selected from a set of predefined characters like lowercase latent letter, uppercase latent letter, digits, and special character. Sorry. Then you will be able to generate strings satisfying the conditions you want them to satisfy. So if you're doing some automation, this might be a proper way to generate some passwords satisfying some requirements. The typical requirements, more or less strict in comparison with these two fields, are password requirements. Then the tools which are used for combinatorial testing, like PICT, can give you nice, can do the job for you, and you will just use the strings generated by those tools. It might not be the proper way to do it with this form, but consider it as an approach. And here, as kind of an exercise for you to do on your own, try to build the model, the model for combinatorial testing in any tool of your choice, or write your own, which takes the dependencies I mentioned into account and any others you can come up with or you encounter when doing your research, and create the set of tests where each parameter, first name, last name, credit card type, number, month, year, CVV, is defined. Consider all of them mandatory. Okay, so it is not possible, it shouldn't be possible to have them empty. That's it. I hope that was somehow enlightening or at least interesting for you. And that's actually it. That's everything I wanted to cover today. If you have any questions, please feel free. But that's about it. Thanks for the great questions and thanks for your active participation, guys. I hope to see some of you in Entelias and hope we can somehow work together. I enjoyed this immensely and hope you had some fun too. If you have any questions, shoot. I will be here for a few minutes more. And if no, then that's it. Please let me know if you want me to come back to some of the slides.
Thank you so much, Hannah. It was actually so great. Let me check if you have any questions. We have a lot of warm words. Thank you. And just people are really grateful for your speech and for this webinar. I just want to remind you guys that I will send the presentation and the recording of our webinar tomorrow to your emails. So if you need something, you can just always watch it once more or reach us if you have any questions. So thanks again for joining, and I hope to see you at our next event. Have a great evening.